So I read from number 4.
Yes, please. Yes, please.
Solar panel is mounted on the roof of a house. Figure 4.1 shows a section through part of the solar panel. A pump makes water flow through the copper pipe. The water is heated by passing through the solar panel. Select and explain 3 features of the solar panel that maximize the final temperature of the water.
Okay, yes, we can discuss about that. We can discuss about it. So in the solar panel, we have trapped air, we have the sunlight coming, we have the glass sheet of material, we have the copper pipe painted black, and then you're having the metal buckling sheet painted black as well. And then we have the insulating material, and then of course the water in the pipes. Yes, so any 3 features that maximize the warming of the water, that is what they want us to discuss about. So what do you think would lead to the water getting hot?
The copper pipe painted black.
And how does that?
As the sunshine is shining on the solar panel, black absorbs sunlight, so the copper pipe painted black becomes hot, which enables the water to heat up.
Okay, that is very good. That is the first feature. Copper painted black, meaning that this is a better absorber of heat, not light in this case. Okay?
Yeah.
You're absorbing the heat, not the light. Okay, now that is good. Anything else? Sunil, Mega, for what do you see?
So I also saw the same thing that Kirtan saw.
Okay, anything else?
Yeah, sir. The trapped air which is in the middle, it heats up due to the heat from the sunshine, which also enables the water getting hot.
The trapped air heats up.
Yeah.
And therefore it is okay. First of all, is that air moving?
No, it's trapped.
Okay. So okay, I can just rephrase that, and I say that the trapped air prevents heat loss by convection. In case you remember about convection, convection is the form of heat transfer in fluids. For example, if this is water and you hit the bottom, the fluids particles are going to simply raise up. And in case this one was colored, then the color simply saturates like that. And in case you remember this experiment here, this is a test tube. We have the water, and then when you hit this surface here, here we have ice, and then a wire mesh, and then the water. In case you remember well, in this experiment here, the water only boils at the surface for some time, yet the ice is still there. We expect the ice to melt, but doesn't melt, meaning that water is a poor conductor of heat. So this circular motion of air of the molecules is what I'm trying to refer to, air convection. Likewise, in case you remember about the breeze, the sea breeze and the land breeze, the air is moving away from the hotter regions going to the colder regions. So the air is flowing, and that is conduction. But in this case here, we're not having the air moving. It is trapped, meaning that whatever amount of heat that it gathers or it gains, that heat does not go away. So it prevents heat loss by convection. That is correct. Mega, anything else that you see?
No.
What if the water was in plastic pipes? Would it get hot fast?
No, it would take some time
And why do you say so?
because plastic is somehow a poor conductor of heat.
And so in this case, what would we propose?
Is an insulator.
In this case, we're having copper.
Yeah,
So how would
copper
we
is a good conductor of heat.
That is number 3.
Sir,
Copper.
I also think
Mhm.
the metal backing sheet painted black,
Mhm.
due to it being somehow thick, as I see. Okay, it being black, it absorbs heat
Mhm.
from the sun, which
Mhm.
is then transferred to the copper pipe.
Okay. Okay, I'll just phrase it like this because I've already talked about something being black, and that means that it's a good absorber of heat. But still, I would simply talk about this. Do you see this shape, the way it is drawn? We have the copper,
Yeah.
we have the copper in the middle.
Yeah.
Assuming that this is a concave reflector. This is an aluminum foil. You've placed it in a basket, and then in the middle, you put there a saucepan painted black. The water in that saucepan will get hot. Why? Because as the heat is coming, it is going to be reflected onto the saucepan. So it is the same thing that we're seeing in this space here. Okay? So we can simply say that the metal backing sheet is concave in nature, which reflects heat onto the copper.
But say it is black.
Yes, that is also another advantage about this.
But will black reflect heat?
No, I'm not talking about the surface being black. Okay? I'm talking about the surface being concave, like this.
Okay.
Yes, so there's some bit of reflection of the heat because of that. But the major one is, of course, yes, black being a good absorber of heat. Okay, another one. How about the glass? How does the glass affect?
So glass is a good conductor of heat.
Glass material?
Yeah.
When you get a glass and then you place it in contact with a flame.
What I say,
the
glass sheet and the trapped air, they work together.
Okay.
The glass sheet allows the heat to pass through, which heats up the trapped air, hence making the water hot.
Okay. Sunil, what do you say? Have you ever, I know that you've ever visited a greenhouse. Why do they put plants in a greenhouse apart from preventing pests and diseases?
To enable proper circulation of water.
Okay.
Like to avoid is it respiration? I'm not good at biology.
Okay, one of the reason is, and the major reason is simply to trap a lot of heat in
So
the
greenhouses are
greenhouse.
cool.
Yes?
Greenhouses are cool. They are not. They don't trap a lot of heat. Like that's why they are called greenhouses, because they don't trap a lot of heat, and they are white reflectors.
Okay, okay.
That's why they keep roses in greenhouse,
Okay.
so that the heat cannot destroy them.
Okay. Have you heard about the earth warming, global warming?
Global warming, yeah.
What does it mean?
The ozone layer is being destroyed.
And what causes that?
Pollution,
Carbon dioxide. Yeah, pollution.
carbon emission.
Okay, carbon emission. Let me see if it is here. It is here.
Actually, I'm doing some research on that. Carbon emission.
Okay, let me first share this and then we watch it. Then we shall come back to our discussion.
All your favorite brands from our official stores in one place.
What is the greenhouse effect? Earth is a comfortable place for living things. It's just the right temperature for plants and animals, including humans, to thrive. Why is Earth so special? Well, one reason is the greenhouse effect. A greenhouse is a building with glass walls and a glass roof. The clear glass allows sunlight to shine into the greenhouse while also trapping the sun's heat inside. This is how a greenhouse keeps plants warm even at night and in the winter. The greenhouse effect keeps Earth warm in pretty much the same way. Earth isn't surrounded by glass, but it is surrounded by a jacket of gases called the atmosphere. In the daytime, the sun shines through the atmosphere, warming Earth's surface. After the sun goes down, Earth's surface cools. This releases heat back into the air, but some of that heat is trapped by the gases in the atmosphere. These heat-trapping gases are called greenhouse gases. Carbon dioxide, water vapor, and methane are all examples of greenhouse gases. Earth needs a balance of greenhouse gases to maintain just the right temperature for living things. But some human activities are changing Earth's natural greenhouse effect. For example, burning fossil fuels like coal and oil releases more carbon dioxide into our atmosphere. These extra greenhouse gases can cause the atmosphere to trap more and more heat, leading to a warmer Earth. NASA satellites are constantly measuring the gases in our atmosphere from space. They've observed increases in the amounts of carbon dioxide and other greenhouse gases. The information from NASA satellites can help scientists figure out where greenhouse gases are coming from and how they are ending up in our atmosphere. This information will help us better understand the impact that greenhouse gases have on our climate and help us better understand this very special greenhouse that we call home. Find out more about.
Okay, I hope that you've got an idea of what greenhouses do. The purpose of the greenhouse, in addition to
trap heat.
Yes, in addition to preventing pests and diseases, in other words, you're planting plants in a place that you can easily monitor. So in addition to that, the major aim is simply to keep the contents within the greenhouse at a fairer, warmer temperature than the outside. That's why even in winter, even at night, when you enter the greenhouse, it is a little bit warm compared to the environment outside. Remember that plants need light to make their own food, photosynthesis. So the more that heat energy is around them, the more the quantity of heat, food that they make, and therefore the faster they grow. Now, the reason as to why we talk about greenhouse effect is that greenhouse effect, just from the word greenhouse, on a smaller scale, the greenhouse effect is the warming effect. On a larger scale, instead of talking about the word greenhouse effect, we talk about global warming. So global warming is simply a gradual increase in temperature of the earth. Global warming, gradual increase in the temperature of the earth. And from this video, it is simply caused by emissions of what you call the greenhouse gases, emission of carbon dioxide. A lot of carbon dioxide traps the heat in the Earth's atmosphere and therefore increasing the temperature. So the reason as why we plant trees is that we know that trees breathe in carbon
Increase
dioxide.
the amount of oxygen.
Yes, they decrease the amount of carbon dioxide in the atmosphere, as well as increasing the amount of oxygen in the atmosphere. But the major aim is to reduce the greenhouse gases and therefore cooling down the earth. So from this video here, what I wanted you to see
Earth is a comfortable place
is this beginning
for
part
living
here.
things. It's just the right temperature for plants and animals, including humans, to thrive. Why is Earth so special? Well, one reason is the greenhouse effect. A greenhouse is a building with glass walls and a glass roof. The clear glass allows sunlight to shine into the greenhouse while also trapping the sun's heat inside.
So that is the property of the glasses in the greenhouse. Sometimes we use glass, sometimes we use polythene. They act in the same way. But of course, glass is expensive. That's why we prefer using polythene bags or polythene. So that is the reason as to why we use that. Now, coming back to our discussion here, the reason as to why we have the glass there is also to increase on that effect of warming up. So glass traps heat. In other words, greenhouse effect. And then another point that we can think about here, Sunil mentioned about it, only that she was not sure, is that we are having an insulating material. An insulating material is just to lower
the loss of heat.
Yes, insulating material.
So, sir, the glass traps heat. It also goes with the trapped air, right?
Yes, it is fine.
It's hand in hand, yeah.
It is okay, it's fine. Reduce heat loss. That is the insulating material. So you can talk about those. You can talk about those. Then the next question is saying that, let me see, okay. The next question is saying, during one day, 250 kilograms of water is pumped through the solar panel. The temperature of this rises from 16 to 38 degrees Celsius. The water absorbs 25% of the energy incident on the solar panel. Specific capacity of water is 4,200, that is 4,200 joules per kilogram per degree Celsius. Calculate the energy incident on the solar panel during that day. So you can hear the words heat capacities, and this is where they are coming in. So, Sunil, what would we do here? Patel, let's give a chance to these girls to discuss for us. Yes, Sunil and Mega, you're welcome.
Yes, sir. We first, the energy equals to power times time.
Energy is equal to power times time, yes.
Energy is also equals to IVT.
Which is the same as IV times T.
So we say I don't know.
Okay. Mega.
Yes, sir.
How far, what do you think? What do we do?
Mm,
Patel, what do you think? What do we do?
So we write M.
Mm-hmm.
M is equals to 250.
Mm-hmm.
What is this thing called?
Specific heat capacity.
Yeah, the specific heat capacity is 4,200 joules.
Mm-hmm.
C, yes. And the change in temperature is 68 minus 16 is 22. The change in temperature,
Mm-hmm.
change in Q, beta, sorry, is
Mm-hmm.
equals to 22.
To be the same as 38 minus 16,
16. Yeah,
giving us
22.
22 degrees Celsius. Okay.
So
Mm-hmm.
we shall say
Mm-hmm.
QE is equals to MC, change in temperature.
Mm-hmm.
Where there is Q, we shall say Q is equals to, 250 times 4 times 22. Let me do it.
Mm-hmm.
250 times 4, 200 times 22. 2 million. No. 23,100,000.
23,100,000 joules. Okay.
So sir, it will be 23. No, let me just leave it like that. Or
Okay.
you can say 23,100 megajoules, mjoules per kilogram per degree Celsius.
No. We're calculating for this is heat. So it is
Oh,
measured.
yeah, sorry.
It is measured in joules.
Yeah,
So you can either say 23.1 megajoules, or you can say 2.31 times 10 to the power of 7 joules.
Sir, if you say 23.1, that will, it will be mega, mjoules.
Okay, but just leave it like this. Okay, do we end up here?
No,
Mhm.
we say power is equals to. We want to find the energy. So
The incident solar energy incident on the solar panel. If they say this is mathematics now.
the water absorbs 25% of the energy incident on the solar panel. 25%. So will it be 25 over 1? No. Yeah, 25 over 100 times 23.1 mjoules.
Okay, it would be this. It would be this, but heat absorbed by the water is equal to 25% of heat incident on the panel. That is what the question says, that water absorbs 25%, and yet we've got that amount of heat energy. So we shall simply say that 100,000 is the same as 25 over 100 times the x. So what is that value of x?
Zero 0.25 231,000 divide by 992,400,000.
Okay, and that is very correct. So, Mega, Sunil, is this fine with you? Have you understood the concept?
Yes, sir.
Yes, sir.
Mega, you are lying me. That response. Okay. I'm going to send it to you such that you look at it again. There's no problem. Okay, so the solar panel in the figure is designed to heat water. A person is deciding whether to install solar panels on her house. List and explain 3 pieces of information she needs to consider in order to make her decision. So what would the person consider in installing the solar panel on the house? What do you think should be considered in this case?
It is a one-time cost. So it is cheap than using heat, than using electric. So let me say it in Ugandan language. It is cheap to use solar panels to heat water to save the costs of yaka.
Okay. Now, the question is saying the person is deciding, so he has not yet decided.
Okay.
And
so I have to convince her, right?
So he just wants to find out. In other words, explain 3 pieces of information she needs to consider. In other words, what should she consider in order to install it, in order to make her decision? The first one about prices, you've talked about it. So the person needs to consider about the prices. Prices of installation. If it is expensive, then he leaves it out. If it is cheap, then he can do that. If he considers the mathematics and finds out that this is cheap, is also okay. So that is one thing that she or he must consider. Any other?
The rate of heat, the amount of water it heats.
Okay. I'm going to rephrase that, and I can say power output of the panels. In other words,
heat the water.
Yes, okay. In other words, does she need 220 watts, 200 watts? Okay, depending on different factors. So that is power output. Then another one would be the shape, stroke size, stroke direction of the roof. The sun is, red direction is, I'm just listing down a few of them that you can think about. So we have, we can talk about the weather, or the weather in that region. Is it a sunny place? Is it a place where you have a lot of winter? All those ones are conditions that she or he must must consider. Environmental. Environmental conditions, winter versus summer and others. Okay, I'm having some 5 minutes here to end the lesson. The sun releases energy as a result of nuclear fusion. You've not yet looked at this nuclear fusion, have you?
No, sir.
Okay, fusion means combining.
But we had started on it, like we discussed something in my school.
Okay, no problem. I can just talk about it briefly. I'll still be meeting it later on. The meaning of the word nuclear fusion simply means the nucleus or nuclei. This is the plural of the word nucleus. Combining to form a heavy, stable nucleus. In other words, this is about radioactivity. We shall be meeting this later on. It is under block 5 when we're ending our block 5. Then, in other words, I can simply talk about it more. The energy from the sun, how is it that the sun can produce energy throughout the years, centuries, and so on? What causes the energy? I mean, what causes the sun to produce energy? So I can simply say that the sun produces energy by a process called nuclear fusion. In other words, one hydrogen atom, nucleus, combines with another hydrogen nucleus to form what we call a helium gas plus the energy. This is not there, plus the energy. We shall be looking at this. This is hydrogen nucleus. Or let me just call them nuclei. I know at the moment it is not making sense to you, but we shall be meeting again and then talk about this. This is nuclei. Nuclei is the plural. And then this is a helium nucleus. Nucleus like that. So whenever those two nuclei combine, they always produce vast amounts of energy. They produce vast amounts of energy, just like a nuclear power station. Then we have this number 5 here. I'm going to leave this one for you to try out. We're going to be using the gas laws. We're going to be using the gas laws. In other words, P1, V1 is equal to P2, V2. Then we shall be using P1 out of T1 is equal to P2 out of T2. And then V1 over T1 is equal to V2 out of T2. So I'm going to choose from each of these ones here, and then you answer this question. And it is also about Boyle's law. Brownian motion. Describe the motion of molecules in the gas, Brownian motion. We shall be starting from here when we meet again next time, but still can talk about each of these. You can just do a quick research about this, and then we shall begin from here when we meet on Thursday. Otherwise, at the moment, let me stop here and I send you this document. You read it through it, and anything related to this. Okay, so have a great day. Let's meet again next time.
Thank you, sir.
Thank you, sir.
Welcome.
So I have a question.
Uh-huh.
Are we going to look at electricity?